remember that actually you started a dialogue with, people on Twitter, and because so much misconception they have that you decide to write a long piece of paper, and that's about to finish, where you're going to explain all the things because you are tired of address all these questions. Yes. Okay.
Yeah, I got so tired of it. I said, all right, I'm just going to write the paper and publish it and settle this matter. So yeah, I've been spending a lot of effort trying to do that, and it's all because of a Twitter argument.
No, I mean, that's all good, Actually, the more people discussing these topics, even it's misconception, but it's actually opportunity to actually make people aware and get things right. It's better than actually people don't even bother to ask anything. So I guess in a way it's a push you to get the paper out, and we're benefit all of us to read it. And I also remember you mentioned that Elon Musk is planning to send 9,000 rockets into space in next 26 months, and I think last time we calculated that's around 12 launch each day. That is like crazy. And you mentioned that it could potentially cause a lot of harm to the environment. And if other companies follow that as well, can you just elaborate a bit on that, and how does that moon mining or moon base will help on these?
Yeah, so SpaceX, which is the company that Elon Musk founded for launching into space, their company's goal is to put 1 million people living on Mars. And Elon has said that he wants to finish this by the year 2050. So just 27 years from now, he wants to have 1 million people living in a city on Mars. And he has laid out his plan of how to do this. He said that it would take about 26 years to accomplish. Now they're not going to start next year. So they're not going to make it by 2050. But even if they start 10 years from now, and then 26 more years, so 36 years from now, there could be 1 million people living on Mars. We're not talking about far in the future. We're talking about things that you will see happen during your lifetime.
Yes.
But his plan is, the reason he said 26 years is because, I'm sorry, 12 years. Yeah, because he wants to, because the moon and Mars and the Earth line up with each other as they're going around the sun. They line up once every 1.2 years. And so that's every 26 months. I'm getting this all mixed up. But anyways, yeah, it's a little over 2 years. Every 26 months, he wants to send 1,000 spaceships to Mars. And each spaceship will carry 100 people plus about 150 tons of capital for mining and manufacturing, so that the city can try to become self-sustaining.
Sufficient.
So you can grow your own food and make your own supplies, and you won't have to bring everything from the Earth. So he thinks it will take 10 cycles. Each one will be 26 months, so 260 months. So what is that? That's a little over 20 years. But each mission that goes to Mars requires 9 launches off the Earth. 1 launch with the rocket that goes to Mars, and then about 8 more that will refuel it so that it has enough fuel to go to Mars. And so that's 9,000 launches every 26 months for 260 months. And like you said, that's like 12 a day. And these are big rockets. Well, and the problem you brought up is that this could harm Earth's atmosphere, because there is a limit to how much we can launch through the ozone of the Earth before we have damaged the ozone too much, and it harms people on the Earth. So this is another reason why we should be mining on the moon, because if you can get that rocket fuel off the moon instead of getting it off the Earth, then instead of 9,000 launches every cycle, you can only do 1,000 launches. So you've reduced it by a factor of 9. And that may be enough to get us down below the threshold where it harms the atmosphere. Like, I read a paper that says they're estimating Elon's plan would be about 7 times too many launches And so if we can divide it by 9, that gets us below the threshold. So I think this is another reason why mining in space will be crucial for us to be able to operate in space without hurting the environment.
So contrary to what other people are thinking, that's, somehow that space mining might cause environment issue. Actually, it helps a lot. And the environment issue it creates is actually able to address, so long as we know what impact it will create, which is pretty much we learn from terrestrial mining. We did all these and we have a modern life, but now look back what is the heavy cost we have to pay environmentally. And that's which we learned, and that's when we do it in the moon or in the space, that which we will take into consideration. But I am surprised that in Elon Musk's plan, he did not actually mention about the moon and the refueling, and somehow it just straight go to Mars.
Yeah. I understand it. I mean, from his perspective, it makes sense, because if you want to settle Mars, you don't want to put a lot of complications on the critical path. So he doesn't want to have to develop a whole industry on the moon as a step to go to Mars. But you see, other companies have the business opportunity to develop that industry on the moon. And once they've done that, they can provide the rocket fuel to Elon, and that will dramatically cut costs for Elon in order to put humans on Mars. So I understand why Elon doesn't want to do it, but it does make sense for somebody to do it.
Totally agree. What would be the 3 business model that you could just right now think of on the moon for the next, let's say, 5 years? I think you mentioned something about the providing, critical service to the government. And if you can elaborate a bit further
So government space agencies want to do science and exploration. And one of the reasons that national space agencies do this is because it is inspiring and because it projects a good reputation for the country. And so that's not an economic calculation. And so they don't make those decisions based on making a profit. They make those decisions based on how it will help their country geopolitically. And so
exactly.
Yes. And so because it's not an economic calculation, they are willing to get started on these things now, even before the economic activities become economic. And so that's a first business opportunity for a company to support the government space agencies. The government space agencies will pay as much as it takes. So you can build landing pads on the moon, and you can mine the moon and get water and provide that water to the outpost, so that if the country has astronauts living on the moon doing science and exploration, they're going to need water. They're going to need rocket fuel to leave the moon to come back to the Earth. They're going to need electricity, so you can provide power systems. And so this is an opportunity to develop all the technologies that you need for industry on the moon and do it at government expense rather than taking on the risk yourself.
Yes, like what you said, with government endorsement, that is just going to be quite a lot of comfort. And apart from that, any other business model, or you think all the business model were centered around serve the government mission?
There are other groups that want to do things in space, like there are groups that want to put telescopes on the moon. And so, philanthropists and others who have not economic motive, not commercial motive, but some motive to do things now. I've heard a lot of other ideas, and I don't know what companies are doing what, because companies usually keep their business ideas secret. So they don't tell me what their business ideas are. But some of the things that we hear companies talking about are putting research parks on the moon to develop medicine or to do biomedical research that is hazardous in order to get it away from the humans on the Earth. We hear companies talking about putting computer servers on the moon. There's a company in Tampa, Florida, that has done a press announcement that they have a customer that wants to put a computer server on the moon. Now, I don't know why they want a computer server on the moon. What is the value proposition? I don't know. But they have a customer that's willing to pay for it. So providing that service, transporting and then maintaining computers on the moon is apparently a business opportunity. I think that in the early stages, developing transportation capabilities, developing the ice mining, these are going to be happening very soon. And then once you've developed the ice mining, then providing transportation services in cislunar space, boosting spacecraft, positioning spacecraft, servicing spacecraft, going back to visit a spacecraft that's already in orbit to repair it or to upgrade the electronics and to give it more fuel so it can extend its life. These are also some early business activities that will be happening. There's a company I know that actually has customers that are putting connectors on their spacecraft so that this company can service their spacecraft in orbit after it's been operating in space. So satellite servicing is becoming another business opportunity.
Wow. And all of these you think will happen in the next 5 to 10 years, right?
I do. Yeah. I think that, I mean, if I had money from an investor to develop lunar mining, I think we could have a lunar mine operating within 5 years. The technology is not exotic. We just need to build it and we need to test it and we need to make it reliable in harsh geological conditions. And so that will take some time. But I think a team of motivated technologists could do it within 5 years. And I had a project funded by NASA. I called it Aqua Factorum. That's Latin. It means water maker. And I was thinking of Harry Potter, the Harry Potter movies where they would say, Wingardium Leviosa with their magic wand. And so I was thinking Aqua Factorum, and we magically make water on the moon. But the Aqua Factorum process was designed to be a minimum viable product. The whole thing can fit on one lunar lander. The whole thing weighs 2.5 tons. And there are lunar landers that can carry 10 tons to the moon. So you can fit the whole system on one lunar lander. It can deploy and it can make enough rocket fuel to boost 3 spacecraft per year, which will triple the revenue from that will triple the cost of developing and launching the system to the moon. Now, it will be a first attempt. So there are risks and it might break and it might not work. But at least in principle, we have shown that you can build a minimum viable product system that will create a net profit from the beginning, from year 1 of operation. And it would take about 5 years to get it ready and fly it. So I think there definitely, if there's investor will, if we have convinced people that the risks are low enough relative to the benefit, I think we could start right now.
Wow. And where are we on these projects? That sounds just like phenomenal, right?
Yeah, so NASA uses a scale we call the Technology Readiness Level, TRL, and it goes from 1 to 9. So TRL 1 means you just had some idea about physics. TRL 2 means you've come up with an idea how to use it in an application. And it goes all the way up to TRL 9, which means you're actually flying it operationally in space. So most of these technologies are TRL 3 to 5. And there are a few that are TRL 6. Now, normally, so let me tell you what that means. TRL 5 means you've built prototype units and you've done integrated testing with the prototypes. TRL 6 means you've done that in a relevant environment. So you've simulated vacuum, you've simulated low gravity, you've simulated the geological harshness of the moon, and you've shown that it works in the right environment. Once you achieve TRL 6, that's the point where you can start building the flight hardware. So then you do the qualification testing, that's TRL 7. You do the flight testing, that's TRL 8. And then you fly it, that's TRL 9. So most of the technologies are around 3, 4, and a few of them are up around 5 or 6. So we do have a lot of work to go maturing these technologies. And that's where we are right now.
Okay. But basically the funding will really help to speed up the process.
Oh, yeah. That's why I said 5 years. I think you could mature these technologies to the point that they're ready to fly a demonstrator on the moon, starting right now at TRL 4 and 3 or 4. Within 5 years, you could have it to TRL 8 ready to launch and get it on the moon.
And I know you personally have been working with, many new space company and helping them research on different theme they want to focus on and helping them to get NASA grants. So over years, I mean, if it's not highly confidential, I just wonder what is usually this kind of process, to gain grants from NASA, and how has the NASA selection process works or have changed along the years?
Yeah, so it's a lot of work to win grants from the government because there's a lot of competition for that money. There are a lot of companies, a lot of people with ideas that they want to try. And so they're all writing proposals to get the money. But the way it works is NASA writes a solicitation and they publish the solicitation. There are 10 or 15 solicitations every year for different kinds of contracts. One of those contracts is for small businesses, and that solicitation alone contains about 30 to 50 topics that they are asking people to write proposals on. So people like me, we pay attention to the emails from NASA, and every time a new solicitation comes out, we go to the website, we open it up and we read it, and we ask ourselves, okay, do I want to try to compete for this money or not? And then we call each other and we're like, hey, I've got an idea. Do you want to be on my team? And so companies talk to each other and companies talk to the universities, and we even talk to government employees and ask them to be on the team. And we put together our teams and then we write the proposals. It usually takes a couple of weeks to write a good proposal. And then we send it to NASA. And then NASA has a review where they will invite a panel of experts to read all the proposals. And I've been on many of these panels, and everybody I know has been on many of these panels. It's like a whole week where everybody stays at a hotel for the 24 hours a day for an entire week. And we meet every day, all day long, to study the proposals. And at the end of that week, they make their recommendations to NASA. And then NASA makes the selection and they notify you, your proposal has been selected. Now, depending on the type of solicitation, the percentage that you win might be really low. Like a lot of the solicitations, you only get about 1 out of 15. And so you have to write 15 times more proposals than the amount that you hope to win. And that's a lot of proposals. Other solicitations have better statistics. Some of them are like 1 out of 6. And so those are the ones I like better, but they're typically smaller amounts of money. So I still end up writing a lot of proposals. But I've been successful. I've been doing this for 8.5 years. I've been winning enough grants to cover my salary, to cover the salary of the students and the postdocs that work in my group. I've been winning enough money to buy all the equipment, to travel to conferences to present our work. And so it's sustainable, but it is a hard process.
Yeah, when you first time mentioned to me, and it's like, wow, I thought the life of academics are, very chill, but it seems like, even more stressful than entrepreneur. Well, you guys are entrepreneur, right? You mentioned that you guys are entrepreneurs. Well, my goodness, thank you for sharing these insights. This is amazing.
Yeah. So we, faculty don't have to report how many hours that you work. And because they don't pay us by the hour, they pay us to be faculty. But most faculty, in fact, everybody I know works way, way more hours than a normal work week. Like we work 60 hours, 80 hours a week. Everybody works really hard. But, I love it because I love what I'm working on. It's exciting.
That's what I mean. One has to have a passion, I thought it's a business word. Sometimes we talk so much about mental stress and work-life balance. I cannot imagine that, professor in the university, you guys actually work longer hours, but it's all about the passion you guys want to work on. And it's just amazing. That brings actually my next topic, which is slightly different about the whole, regulation and the law environment. And we have US and Luxembourg have its national law. And this is a topic I always would love to hear each guest's view. Do you think with that will be a lot of national law come out there, the space will be more like starting to be divided and, the government might potentially ask for tax, and are there a lot of geopolitical tension will cause? What's your view on that?
Yeah, that's a really important topic. And I don't think there are any easy answers. I think it's really important for humanity to start developing space. So I think we need to press ahead and we need to make the answers to those questions. But I think we're going to have to figure it out as we go along because there are no easy answers. We have a treaty, and every spacefaring nation is a signatory to this treaty. It's called the Outer Space Treaty. And that treaty says that no nation is allowed to have national territory on any celestial body. So the United States and Luxembourg, China, Japan, none of these countries are allowed to say this part of the moon is my country. There's also a requirement that everything we do in space needs to be for the good of all humanity. If you interpret that one way, that might tell you you're not allowed to do space mining because who has the right to go take a resource off the moon and use it for some purpose? Who gets to decide if you're doing it for the good of all humanity or not? And so
precisely.
Yeah. And so it's a big uncertainty. And part of the problem is that this treaty was written back in the 1960s. And at that time, we weren't thinking about mining the moon. All we were thinking about is not having nuclear weapons in space bombing people on the Earth. And we didn't want war in space. And so they didn't discuss or decide some of these really important issues. Well, I talked to a lot of attorneys who study these topics, and what I'm hearing from them is that they don't believe we need a new treaty. They think that they can work within the existing Outer Space Treaty, but what we need to do is establish international precedent so that countries will start to behave certain ways, countries will start to agree with each other, and then over time we will decide, okay, these are the norms, this is the interpretation of the treaty, and the international community agrees on it. And so it's going to take time to actually start to go out in space and operate in space and establish the precedent. But there's one more aspect to this. Because of the uncertainty, because we have not settled these issues yet, some of the countries on the earth are trying to take away the risk so that investors can still operate in that environment. And the way the countries are taking away the risk is they're passing their own national laws, which says the interpretation of Luxembourg or the interpretation of Japan or the interpretation of the United States is that if you operate on the moon and you extract a resource, you own the resource. You don't own the land that you operate on. And if you're using that resource for economic activity, then in general, economic activity does help the whole world. So these are the interpretations of individual countries. And what they're basically saying is, we will not take you to court. We will stick up for you if you want to operate this way. And so that does reduce the investor risk. And that gives us the freedom to start establishing the precedent in space. Now, I'm not an attorney. I might have said some of that wrong, but for the sake of your viewers and your listeners, at least that's what I think it means. And that's the way I interpret it.
Yeah, absolutely. And I agree with you. The treaty is so vaguely written, pretty much outdated because it was written from a different, I would say, different vision. And without the national law of US and Luxembourg and some of the other country to follow, it's very, very difficult for the private sector to really blossom. So I absolutely 100% agree with you. And yeah, please.
I think that there's a good analogy to harvesting icebergs in the ocean. So icebergs will break off from various parts of the world, Greenland, Antarctica, and then float in the ocean. And there are some countries that will go out with a ship and grab the iceberg and haul it into their port and use that as fresh water. According to the law of the sea, if you go haul something out of the ocean, you extracted it from the ocean, you own it, but that doesn't mean you own the ocean. And so as an analogy, if you go out and you get a small asteroid and extract resources, then you're not claiming ownership of a celestial body, you're just extracting. So there are some other analogies to law here on the earth that I think are helpful.
That's very clear. Yes. Okay, good. There is a path to go. And yeah, it is. I think that the law probably is a bit behind the technology development, right? With so much going on, for sure, I think we're going to see some quite interesting development over that part. And like what you said, it will be good to establish some international precedent. So then there will be enhanced more collaboration. And sometimes, like the current situation between China and the West, the tension, but in a way, it's also helped like almost kind of competition, like a space is like, everybody just wanted to, keep each other on the toes. Everybody is, moving forward, but it were also good to see there's more collaboration. So not every, country has to reinvent the wheel, and there's some kind of different focus and work together. I was actually reading an article by Cyril Priestley, and he was talking about the traditional industry, invest into the space industry, and its subsector like 3D, alternative fuel, and even agri-tech. So what industries, according to you, should start to invest money into space and potentially can make a huge return out of these investments?
First of all, the real easy ones would be robotics and artificial intelligence, machine learning software. There's a direct, immediate application of those technologies for operating in space. Also, some of the technologies that we need for operating on the Earth have a version for operating on the moon. And for example, 3D printing houses. So we talk a lot about 3D printing buildings on the moon for radiation protection. And those technologies that can do construction on the moon can also be used on the Earth. So by using government funding, government grants to develop these technologies, you can then spin them off and use them in terrestrial applications as well. So we call those dual use technologies. And there's actually a lot of dual use technologies, anything for mining, manufacturing, for processing of gases, electrolysis. A lot of the industrial processes that you would use on the moon have a benefit here on the Earth as well. 3D printing with metal to make parts that you can use in your industry on the moon. So any company that works in any of those industries can start to modify their technologies for application on the moon, and can sell those technologies to the government, can sell those technologies to companies that want to do other activities like mine in space. And I think that could be a business opportunity for them.
Absolutely. I can immediately think of my previous life in the terrestrial mining. I think, actually the robotic, the artificial intelligence, could eventually replace all the humans. So they don't, people don't have to go to underground. That's going to massively save the OPEX, remove the human out of these hazard environment and make the whole entire mining potentially underground, maybe a lot more efficient and better for environment.
Yeah. So, right now you might have one operator teleoperating a robot to mine. But pretty soon we may have one operator teleoperating 3 robots, and then pretty soon it'll be one operator for 10 robots. And eventually you might have like 2 or 3 operators monitoring 100 robots operating on the moon. And it only takes 2 or 3 people to monitor the whole operation. And so, and by the way, that's how we reduce the cost. And that's how lunar mining becomes more and more economic and more competitive, because we're reducing labor costs. And so that's robotics, and that's machine learning, artificial intelligence. And right now we're making tremendous advances in these fields. And those are the same technologies we need for operating on the moon.
Yes, we shouldn't forget that the technology for space is actually for the better living of Earth. Okay, and I remember that our last conversation, you mentioned that the biggest aspiration for you, in space is to actually democratize the space resources and let as many people to participate as possible, because you don't want, all the resources just end up in these few privileged billionaires. And, can you just elaborate that further? And I thought it was so thought-provoking and, it was fascinating.
Yeah, this is kind of way out there, but so if you just think big for a minute, let's think really, really big. Where is this all going? We're going to have robots, and the robots are mining and they're manufacturing, and we're getting more and more robots controlled by fewer and fewer people, until eventually you have a whole supply chain operating in space. All the resources you need to build everything are available on the moon and asteroids. And so you could have a whole industrial supply chain to make anything. And so the robots can eventually make more robots. And it's not going to be a self-replicating robot, but it'll be lots of factories making parts, other factories putting them together. And so it's a whole self-sustaining supply chain. And it will be fewer and fewer humans required to create all of this value. Pretty soon, it'll reach the point that the owners of that industry don't need any more human labor. They don't need any more investment, because the industry itself is a complete supply chain. It can make everything they want. So they will never have any reason to dilute their equity anymore. And we call that point the ignition point. Once you reach ignition, then the industry in space can start to grow exponentially with nothing else from the Earth. And I've modeled this, and the modeling shows that within about 20 years of ignition, it could have 1 million times the industrial capacity of the entire United States. That's the power of exponential growth. And so if that industry is only owned by a handful of people, like a few billionaires, and if let's say they somehow manage to avoid diluting their equity, and then it grows to 1 million times all the value of planet Earth, then the people on Earth would never be able to buy any appreciable share of equity in that company, because everything we have is only 1/1,000,000th of the value of what that company produces. And so So there's, and I think it's inevitable that we're going to get to the ignition point. I think it's going to happen this century. It might happen by 2070. It might happen by 2050. I don't think it's that far away because the technologies are growing so fast. So I think we have a very short window of time, between now and ignition this century to dilute the equity of that space industry, to democratize it, to ensure that people all over the world own that industry so that once it begins to scale up, the value of everybody in every country, every race, every creed all over the world maintains equal equity with everybody else so that we all become owners of this great future that we have. I think this is kind of sound kind of crazy, but I really don't think I'm exaggerating. I think this may be the biggest challenge humans have ever faced. And we've only got like 40 years to solve it.
Why 40 years? Oh, you mean this century, right? This century.
Yeah.
Sorry.
Like 40 to 70 years to the ignition point. We don't know how long we have, but the clock is ticking. We're already using up valuable time. We need to find ways to make everybody a participant in space.
Absolutely. And I think this is just getting people thinking about it. I think that with so much things going on in the world, people probably didn't even realize that is what is going to happen. And we are so close to, you call it ignition point. And can you just actually give a bit more explanation or more bit definition on the ignition point?
Sure. So right now, if you study how industry grows here on the Earth, there are certain things that govern the rate that industry grows. And the economists study this. In macroeconomics, they look at the factors of production, labor, capital, natural resources. There's also government taxation policies, and all of these affect the rate that industry can grow. But once we have established a self-sufficient industry based entirely on robotics with artificial intelligence, it no longer requires the natural resources of the earth. It gets all the energy from solar panels that it makes on its own. It doesn't need labor because it has robotics. And it's out there in space where it has some level of insulation from regulatory powers of government. And once that gets established, it's not really like an industry anymore. It's more like a life form because it has a metabolism. It eats, it gets resources from the environment. It processes the resources. It reproduces and it grows. And for example, if you put bacteria into sugar water, that bacteria will double. The population will explode until it uses up all the sugar in that cup very rapidly. And that growth of the bacteria is exponential. Doubling. And so once you've established industry so that it can begin doubling, that's the point that you've reached ignition, that it's more like a life form than a classical industry on the earth.
Got you. And that will only happen in the space, or that could happen in other industry on the earth as well?
Well, you could do it on the earth, but the problem with doing it on the earth is that to grow an industry that large, you would use up all the resources. You'd have to destroy all the forests and all the ecosystems. And it would be really bad for the planet. There's a certain, like a planet is we think of a flat surface goes out to infinity, but one of the biggest shocking discoveries of history was that we live on a globe. And that means it's actually a finite amount of space. And so our civilization can only grow so much. And eventually you fill up that entire space. And so that's the planetary scale of civilization. a civilization cannot get bigger than the planetary scale unless it gets outside of the planet. And because we are currently hurting our planet, global warming, starting to deplete some of the better resources, we are starting to feel the effect of being on a finite planet. So we aren't at the limit, the planetary limit yet, but the closer we get to that limit, the more we harm the environment. So it's already time to start thinking about getting outside of that planetary scale so that civilization can grow larger without harming this most important planet in the solar system, planet Earth, the one special life support planet that we know of in the whole cosmos.
Absolutely. And that's come back to what at the beginning you said, and that's why we are going to space, right? And that's all the starting point to protect our Mother Earth. Yes. And I have a last question, and that's very much related to when I talking to investors about invest into space. A lot of analogy they were using was compared to the 90s internet and maybe 2000, crypto, all starting. And obviously everyone can see, the giant upside, but they also feel that along the way there's a lot of bubbles, there is a lot of volatilities. How do you see that analogy, and do you agree, or what do you think?
Yeah, there's definitely investor risk for getting into space, but I think it's. I'm not an expert on this. I'm not an expert on bubbles, but what I'll say is this, that data and the use of data in our civilization is growing exponentially. I don't think that's ever going to slow down. We've got the internet, we've got people, basically the whole world is starting to become users of the internet, but now we're creating artificial intelligences and we're creating more software that does processing of data, like running computer simulations to develop better airplanes, running computer simulations to predict the outcome of elections so that you can figure out how to be a better politician. You can simulate and you can simulate everything, and it creates value. And so there's always going to be increasing demand for data. And this is why people are talking about putting computer servers on the moon. Now, I don't know how they have a business case right now today, but I think in the long run, we're going to have to push most of the computing off of the Earth into space. But because data is growing, I think that means that space is generally a safe investment, because right now today, the biggest application of space is data. We put satellites in space to transmit data. We put global positioning satellites to create data about our locations. It's all about data. And so if you can mine the moon and get rocket fuel and boost those satellites into their orbit to provide data services, you are becoming part of the biggest growth industry that I think there is. So I think that does give us some insulation from the ups and downs of these market cycles. But beyond that, I don't know. I'm not an expert on bubbles and market cycles.
But that's very, very well said. Actually pull us back from, obviously, we today focus a lot on the deep tech of space mining, but actually as right now's usability is very, very real, and it's very much in need. Yes, and sometimes people think that invest into space is a very, very, very long lead time. But without they noticing it, our day-to-day life now is very dependent on space technology.
It is.
Absolutely.
Yeah, you and I are talking right now. I don't know how the signal comes from where you are to where I am, but I would not be surprised if it's going through space right now.
100%. Well, literally, I have, I only went through probably 30-40% of the question I prepared, but I think we can go on for hours and hours just because, the answer you give is so, elaborating and, just from the answer will grow to more questions. But, I realized that in the past almost an hour and a half, you haven't even drink a sip of water, but you are the one doing most of talking. So I think, yes, we probably need to have another session for a lot of things I would like to, I'm sure listener would love to hear more as well. And before we finish, just for the audience or for our listener out there, what's a message you most want to get to them? Or what is the key takeaway that you would like our listener to remember and to pass on?
Yeah, I would like to give you a little bit of the big perspective that I think we are living on the cusp of the biggest, most revolutionary thing that will have happened in human civilization up to this point. And that's the point where humans get beyond the limits of our planet and we become a spacefaring civilization. And we tap into the millionfold and billionfold greater resources of our solar system, and civilization expands, and it becomes an amazing thing, far better, far different than we know today. And we are the people that are making that happen. That's what a privilege that is, to get to be the generation that makes humanity leap beyond planet Earth into space. And so right now, everybody listening to this has an opportunity to participate in various ways. But I also think there's the danger that if we don't get enough participation globally, then the outcome could be bad. And so I think it's really important for all of us to look for ways to participate in space, to do our part, and to help us all go forward together.
Oh, thank you so much. Thank you, Phil. What you said just now made me feel like, whoa, I am in this journey with many of great scientists and engineering, and the fact that, I can have these podcasts and invite, great minds like you and to discuss these things is just make me feel so privileged. And thank you so much for, bring this message. And I hope our listener, when they hear this message, just feel how I feel, like supercharged and want to be onto this journey and want to get there sooner, make it a reality faster.
I hope so.
Thank you. Thank you.
All right, Julie, it was great talking with you. It's always great talking with you.
Yeah, absolutely. And what's the best way if any listener want to reach out to you or want to give you any feedback? Is that your Twitter is the best way to contact you?
Yeah, that's really pretty much the only way to get a hold of me. It's I'm at Dr. Phil Till. That's DrPhilTill. Dr. Phil Till.
Perfect. Well, thank you so much. The privilege is all mine. Thank you so much. Thank you.
Thank you, Julie.